Okay, for number 1, they want you to solve by using the quadratic formula. So let's write down the quadratic formula up here. So it's the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. So our a value is going to be 1, our b is 8, and our c is 12. So let's substitute these values in. So the opposite of 8 plus or minus square root of 8 squared minus 4 times a times c divided by 2a. Simplify. Opposite of 8 plus or minus 8 squared is 64. Negative times a positive is a negative. 4 times 1 times 12 is 48. So that becomes 16 in here. 2 times 1 is 2. So we can simplify that. Negative 8 plus or minus 4 divided by 2. It's going to give us two solutions. Negative 8 plus 4 is negative 4. Negative 4 divided by 2 is negative 2. Negative 8 minus 4 is negative 12. Negative 12 divided by 2 is negative 6. So we have negative 6 and negative 2 as our solution. Okay, number 2. They want you to use the quadratic formula again. So 3x squared equals, let's distribute the 2 in. So we have 4x plus 2. Move all the terms to the right hand side. So 3x squared minus 4x minus 2 equals 0. 3 is your a, negative 4 is your b, and c is negative 2. So the opposite of b plus or minus the square root b squared minus 4ac divided by 2a. So let's simplify this. So 4 plus or minus negative 4 squared is 16. A negative times a positive times a negative is a positive. 4 times 3 is 12. 12 times 2 is 24. 16 plus 24 is 40. 2 times 3 is 6. We can leave it like this. Number 3, evaluate the discriminant. It's in correct order. Remember, the discriminant is b squared minus 4ac. So for this problem, a is 2, b is 7, and c is negative 15. So b squared minus 4 times a times c. It's going to be 7 squared is 49. A negative times a positive is a positive. 4 times 2 is 8. 8 times 15 is 120. So we're going to have 169. That's the discriminant. It's positive, so that means you're going to have two real solutions. So that's the discriminant. That's the number of real solutions. Solve by using any method. We're going to use the quadratic formula for the first one. So let's move this 5x over. So 2x squared minus 5x minus 1 equals 0. So let's plug these values in. So the opposite of b plus or minus square root b squared minus 4ac all divided by 2a. Opposite of negative 5 is 5. Negative 5 squared is 25. A negative times a positive times a negative is a positive. 4 times 2 times 1 is 8. So we're going to have 33 here, all over 4. And that's your answer. This one, what I'm going to do is I'll use the graphing calculator. So turn it on. Let's get rid of this. Clear that out. So we have x squared minus 3x minus 8 graph. Second, trace 2. So left bound anywhere above it. Right bound under it. Guess, so negative 1.7 is good for here. So negative 1.7. And then let's look at the other one. Second, trace 2. Left bound is going to be right under it, then right above it, and then guess. 4.7 is your other answer. So those are your approximate solutions. Alright, number 6, write a quadratic with the given solutions. Okay, today we talked about a quicker way to do this problem than I did on 4.7a video. What we talked about was in the quadratic, the coefficient of x is the opposite of the sum of the roots. So if I can add the roots together and then take the opposite sign, we can plug that in for the coefficient of x. And then for the constant, we talked about the product of the roots. So the first thing I'm going to do is I'm going to add these two together. So negative 5 plus root 13 all over 2 plus negative 5 minus root 13 all over 2. They have common denominators, so let's put the 2 underneath. Now let's add across. Negative 5 and a negative 5 is negative 10. Positive root 13 and negative root 13 cancel. So negative 5 is the sum of the roots. If I take the opposite of the sum of the roots, which would be positive 5, that's going to be this right over here, the coefficient of x. Now let's find the product of the roots. So we're going to be multiplying these together. The denominator is going to be 4 because 2 times 2 is 4. The numerator, remember, is f times, well, the first times the first. So negative 5 times negative 5 is 25. And then the l's together. So root 13 times negative root 13 is negative 13. So when we do this out, we're going to have 12 over 4, which is 3. So we're just going to put plus 3 equals 0. And this is it right here. So the product of the roots here goes at the end. That's the product of the roots, R1 times R2. The opposite, the sum of the roots, so positive 5 would go here. So this is the opposite of the sum of the roots, right over here. Number 7, so we're going to complete the square here. So we have x squared minus 8x minus 20 equals 0. Let's add the constant term over. There's no factoring of the lead coefficient because the lead coefficient is 1. So we're going to take half of this, negative 4, then we square it. So we get 16. That's what we do on this side. This is now a perfect squared trinomial. It's x minus 4 squared equals 36. Then we take the square root of both sides, so we have x minus 4 equals. The square root of 36 is positive or negative 6. So I add 4 to this side, and this will give me 2 roots. Positive 6 plus 4 is 10. Negative 6 plus 4 is negative 2. So those are my solutions. Number 8. Alright, it's parallel to this line. They want you to find another line that's parallel to the one given. If it's parallel, it's going to have the same exact slope. And it passes through that point. So knowing these two pieces of information, we can write this in point-slope form. So y minus y1 equals slope times x minus x1, so it would be plus 1. Now I want to get rid of this denominator, so what I'm going to do is I'm going to multiply both sides by 3. So I get 3y minus 15 equals, this 3 cancels with this. So if I distribute the 2 in, I'm going to have 2x plus 2 here. So remember, the standard form is ax plus by equals c. So we want all the x's and y's on the left. So I'm going to move this over and this over here. So when I move it over, I'm going to have negative 2x plus 3y equals. If I add 15 to 2, I get 17. Now it's almost in standard. Standard form, you want a to be positive. So because a over here is negative, I'm going to switch the signs of everything. And there's your answer. Number 9, what's the y-intercept of the quadratic function? So to find the y-intercept, what I'm going to do is make x equal to 0, and then solve for y. So we can do this out. Negative 7 squared is 49. 49 times 3 is 147. 147 plus 4 is 151. So that's the y-intercept. Write out an explanation on the steps necessary to arrive at the answer for number 9. Well, basically you can write this out. You would write out the fact that you would set x equal to 0 and solve for y. That's basically all you need to do. You set x equal to 0 in the equation and solve for y in order to solve for the y-intercept. Would this process always work for this kind of problem? Yes. Yes, it would always work.